Okay, so today is the last lecture on electric force and electric field. Quick revision. If two charges are placed next to each other, they will exert a force between them. The magnitude of the force is found using Coulomb's law, which is F equal K Q1 Q2 over D square. The direction of the force is determined by the sign of these two charges. If they have equal sign, that is both negative or both positive, they repel. If they have opposite signs, they attract. If I put an electric charge in space, it will create around it an electric field E. How to test this E? I put a test charge Q. So I place a test charge, and this charge will either get attracted or repelled. That is, it will feel a force. A test charge will feel a force F. Okay. The direction of the force is determined by the charge itself. If it is positive, then E and F will be in the same direction. Okay. If the charge is negative, then E and F will be opposite directions. The magnitude of the electric field E is KQ over D square, where this Q is this Q. Okay. The Q that creates the electric field. And F is equal to the test charge times E. So this F, this Q is the test charge times E. Let's solve one last problem on this topic. So a small plastic ball of mass M equal 2 grams. 2 grams is 2E minus 3 kilograms, or 0.002 kilograms, is suspended by a string of length 20 centimeter. 20 centimeter is 0.2 meter. We divide by 100. In a uniform electric field, E as given here, it is 1 times 10 power 3 Newton per coulomb. The ball is in equilibrium when the string makes an angle of 15 degrees. So I have theta. This is theta equal 15 degrees. Okay. So what is happening here? There is an electric field and it pulls the ball in this direction. Implies there is a force in this direction. So draw free body diagram on the ball. So this is the ball. I'll put all the forces. First, there is the weight. Downward. Then there is the tension in the string. Okay. Then there is this F. And so there is the weight, the F due to the E, and the tension force. Then I have to choose x-axis, y-axis. So this will be x-axis. This will be y-axis. Okay. We notice that W and F are along the x-axis and the y-axis, but the tension is not. So let's get its components, because most probably we will use its components. Let's draw the components. So we will have Tx along the x, then we will have Ty. Okay. This is the angle 15. This is theta here. So Tx is opposite to the angle. So Tx will be T sine theta. Ty is adjacent to the angle. So Ty will be T sine theta. Okay, so let's get them because we will need them. Ty will be T cosine theta. Tx will be T sine . So again, This angle 15 is here. Tx is opposite. Opposite implies it is t sine theta. And ty is adjacent, so ty is t cosine theta. So this is part A. Let's start by part B. Using Newton's second law, determine the magnitude of the tension in the tension force. Okay, so Newton's second law is summation of fx equals zero here, because the object is in equilibrium. Equilibrium implies at rest. Okay, or summation of fy equal to 0. So let's see which one will solve the problem. So if we take summation of x equal to 0, it means f minus tx is equal to 0. Okay, implies f, which is, I don't have f as a value, but I can get it from E. So it is Q times E. But again, I don't have Q. I don't have the charge. So summation of fx will lead me nowhere. So I have to use summation of fy equal to 0. What do I have on the y-axis? I have ty minus w is equal to 0. Ty is t cosine angle theta equal minus mg is equal to 0. Now I just plug values. So t cosine 15 minus m2 e to the minus 3 times 10 is equal to 0. I get t is equal to 0.021 Newton. Okay. Using the Newton's second law, determine the magnitude of the electric force on the ball. Now I will use summation of fx is equal to 0. What do I have on the x-axis? I have f minus tx is equal to 0. So f equal to tx, which is, what is dx? It is t sine angle theta, which is t is 0.021 times sine angle theta, which is 15. And I get this to be 0.0054. Part D, deduce that net charge on the ball. So here I will say F is equal QE, absolute value of the Q times E, implies Q, absolute value of Q, is equal F over E, which is 0.0054 divided by 1 e to the 3. This gives me 5.4 Coulomb. Now, is it positive or negative? It is positive if E and F have the same direction. It's negative if E and F has opposite direction. Here, E and F have same direction, but E and F have same direction implies Q is positive. Okay. So Q equal plus 5.4. So that's it. This is the last problem in this chapter. We will start new chapter tomorrow.